Hello guys, welcome back to Mathematics Made Easy Volume 3. Here we'll be picking another topic from the advanced mathematics. So next volume we'll be picking a topic from the basic aspect of mathematics. The topic we'll be dealing with today is logarithm. Logarithms deal with numbers that can be simplified using basic rules or formulated tables. The logarithm of a positive number, let's say n, to the base a is defined as the power of a equals to n. That is, a raised to power x equals to n, where this s is the logarithm of the positive number to base a. So that's why I said logarithm of a positive number to a base a is defined as the power of a. So the logarithm is the power of a here now equals to the number. That is, s is the what? Logarithm of n to base a. So this is how we represent logarithm. So logarithm of a number, a positive number, to a base a is defined as the power of a. You can see now, a will carry this now. It's defined as the power of a equals the number. So that is the reason why there is a relationship between indices and logarithm. Here now, we'll be learning the rules that govern operations on logarithm, and as well as the use of tables to solve problems involving logarithms. So we'll start from the rules. So the first rule we're going to consider is multiplication rule, or you say law. So you can see it as multiplication law or product law, or you say product rule. So the law states that if you are adding two logarithms of numbers of the same base together, you simply multiply the numbers. So this one will simply give us m times n base a, and that would be what? Log mn base a. So if I are given log of two numbers, they must be of the same base. If they are not of the same base, you cannot apply this. Rule number 2, which is normally called the division law, or you say quotient law or rule. The law says if you are subtracting, like if I are given, let's say, log n base a minus log n base a, if I give something like that, so this one they are subtracting. In case of this, you divide. Just like the way we are written in this is that when you multiply, you add. When you divide, you subtract. But in this case, when you add, you multiply. And when you subtract, you divide. So this one will simply give us log m divided by n. I think we can say that now, base a. So that is division rule. So let's move to the next rule. Rule 3. We normally call this one zero law. And this one says that whenever you are given logarithm of 1 to any base, the result is always 0. The result is always 0. So logarithm of 1 to any base is always equal to 0. So rule number 4 is the power rule, or you say power law. Here, if you are given logarithm of a number and that number is carrying power, let's say it's carrying power of p now, here to base a now, the rule says that the power will multiply the logarithm of that number to the base. So this one will simply give us p multiplied by what? Log m base a. So this is the power rule. So whenever I call something like this, you should know the power will multiply the logarithm of m to base a. Take note, assuming is the base that is carrying the power, let's say this one is in the form of, let's say, log m base a raised to power p. In this case, all we want to do is the power of the base, use the inverse to multiply the logarithm. Like log m base a raised to power p now will simply give us the inverse of p, which is 1 over p, multiplied by the logarithm, that is log m base a. So if it is the number that carry the power, simply use the power to multiply the logarithm. But if it is the base that carry the power, use the inverse of the power of the base to multiply the logarithm. As simple as that. So let's move to rule number 5, which I will call the identity rule. The identity rule. Now, in case of identity rule, it states that if you are given logarithm of a number to the same base, I take for example, assuming you are having log a now, base a, you can see that now. That is, the number and the base, they are the same. The rule simply says it will be equal to 1. So whenever you are having logarithm of a number to the same base, the result is simply 1. Like log 2 base 2 is 1. Log 10 base 10 is 1. Like that. So let's move to the next rule. Rule number 6. Inverse property of exponents. This rule states that if you are having a number, let's say a now, and is raised to the power of logarithm of another number to the base of that same number that carry the logarithm, the law simply says it will be equal to the number of the logarithm. And the last law we are going to consider here is change of base. Now, how do you change the base of logarithm? For instance, if I give you, let's say, log m base a, and you want to change the base of this logarithm to another base, the rule says you introduce another base to it by saying this ought to be log m base, let's say, c now. Can we see that now? So I have changed it to another base, but this one will now be divided by the first base now will become number, then to the same base. So that's how to change base of logarithm. Introduce another base, but they must be the same, where the first base becomes the number. From the laws I've explained, for all a not equal to 0, that is the base that we have been considering must not be equal to 0. Once it's equal to 0, then you cannot do anything. So for all a not equal to 0, all those laws can be applied. But before we move to word examples, I would like to introduce to the types of logarithms that we have. Types of logarithms. There are 2 types. There are 2 main types of logarithm. We have the common logarithm. In case of the common logarithm, this is the logarithm in which the base is 10. The logarithm in which the base is 10. So thus, if I give you like let's say log n, then the base now is 10, you can see it like this, or you just see it as logarithm of n like this. Whenever I say logarithm of n like this without any base, you should know it's base 10. So I normally call it common logarithm. So the logarithm in which the base is 10 is what we call common logarithm. So remember, the second type of logarithm is what we call natural logarithm. In case of natural logarithm, the logarithm in which the base is the mathematical constant e and this mathematical constant e, where e is equal to 2.718 and so on like that, is what we call natural logarithm. So if I have something like let's say log n now base e, you can see it as log n base e, or you see it as ln n. So you see that you see it as this or this. So whenever you see ln or you see log of a number to base e like this, you should know they are referring to natural logarithm. The logarithm in which the base is mathematical constant e, and this is the value, if you check, is always called natural logarithm. So I take note that the laws that we have learned are applicable to the two. So let's consider the following examples. So let's start from the basic ones. If I have to simplify log 27 base 3, to solve this is very simple. We are not new to condensing large numbers. Now, you find a way in which you condense the number given to be of the same base with the base of the logarithm. So here now, all what you need to do is you condense 27 to be of this base. You know that 3 multiply itself 3 times is 27. You'll be having log 3 raised to power 3 then base 3. And from the laws you have learned, I told you that whenever you have power from the power rule, the power of the number will multiply the logarithm. Don't forget. So here now you simply say 3 times log 3 base 3. And from identity rule, I said if I have a number to the same base, it's always equal to 1. So log 3 base 3 here will simply give you what? 1. So we're having 3 times 1. And what's 3 times 1? 3. I believe you can see that. As simple as that. Another example, if I have to simplify or give you a similar one, let's say log 64 base 2. It's easy to solve. Just condense 64. So what's 64? 64 is 2 raised to power 6. So multiply itself 6 times to give us 64. So we have condensed to be of the same base now. Can you see that now? So what was the law? Power will come back, multiply the entire logarithm. And this is identity law. Logarithm of a number to the same base is what's 1. So that will be 6 times 1. And that will be equal to 6. As simple as that. Let's consider another example, basic ones. If I have to simplify, let's say log 81 now, base 3, let's say base 1 over 3. Now, we should first condense 81 to be log 3 raised to power 4. 3 multiply itself 4 times base 1 over 3. You can see that the number and the base are not the same. So how can you simplify this? I gave you a law earlier that you can express the base to be a form of power. And I said power of the base, if also is multiply the entire logarithm to be the inverse that you use to multiply. So what I want to do here is change 1 over 3 in form of power. That is, this is inverse of 3 now. So you can say 3 raised to power minus 1. 3 raised to power minus 1 minus 1 over 3. And apply the law. From here, from the number, don't forget that 4 will multiply the entire logarithm. But don't forget that the base is also carrying power. And I said in the case of the base, what do? You multiply by the inverse of the power of the base. So 4 will multiply, and inverse of the power of the base will multiply the entire logarithm. And what's the entire logarithm now? 3 base 3. I think you can see that now. As simple as that. And 1 divided by minus 1 is still minus 1. So 4 times minus 1 will be minus 4. Then times log 3 base 3 is 1 from the identity log. The final answer will be what? Minus 4. Simple as that. Let me give one more example under this. If I have to simplify, let's say log 16 now, base 2 raised to power 2. It's very simple. What will be your result? This one will simply give us log condense 16 to be form of base 2. 16 is 2 raised to power 4. Abi base 2 raised to power 2. So from that law, what I say will happen? This one will come, abi. If I consider power of the base, it will be what? Inverse. Then times what was left? Log 2 base 2. And here we are dividing. 2 will divide 4. That will be 2 now. So that will be 2 times log 2 base 2 is 1. So your answer will be 2. So as simple as that. Let's consider another example. Let's say if you are given log 8 base log 1 over 4. So simply apply the knowledge of the law. Condense 8, that will be log 2 raised to power 3. And don't forget that 1 over 4 can still be changed to inverse of 4, that is negative power, which is 2 raised to power minus 2 like that. Since 4 is 2 raised to power 2. So, and apply that law, power will come to the back. So we're having 3 log 2 divided by minus 2 log 2. So what do you notice? Since this is division, log 2 can divide log 2. So what will be left there? 3 divided by minus 2. It should be minus 1 whole number. 2 in 3 is 1 and 1 over 2. Let's consider another example. The one involving addition and multiplication. Let's say you are given log 4 base 2 plus, let's say, log 2 base 4, then minus log 5 base 25. I'll use this one as an example. Once you understand what you are doing, here now you can see that all of them are not of the same base. You have to simplify separately. So like this now, it's easy to simplify. Simply condense 4 to be 2 raised to power 2. And here condense the base of 4 to be 2 raised to power 2. And 5 as well to be 5 raised to power 2, because of the power 2 is 25. And apply the laws that you know. In case of this, 2 will come to the back and multiply log 2 base 2. Here, I told you the power of the base will come to the back as inverse. Then log 2 base 2. Similarly here as inverse log 5 base 5. And what's log 2 base 2? 1. 1 minus half times 1. It should be 2 plus 1 over 2 minus 1 over 2. If fraction can go over 1. So the daily sum of 1, 2, and 2 is 1 into 2 times 2, 4. Plus 2 into 1, 1 times 1, 1 minus 2 into 1, 1 times 1, 1. So we're having 4 plus 1, 5 minus 1, that will be 4. Divided by 2. So the answer will simply be 2. Another example. If we are given log, let's say it's 2.5 base 5 minus log 1 over 2 base 5. Here now you simply apply your division laws. These are six subtraction and they are of the same base. You can see that you can apply your division law. Because you can't solve all these ones separately like that. Let's apply the law first. And what does division law says? When you see subtraction, you divide. So we're having log 62.5 divided by 1 over 2 base what? Base 5. And 62.5, you can express it in form of fraction, which should be what? 625 divided by 10 divided by 1 over 2 base 5. So we're having log 625 divided by 10, then times 2 over 1. So when you change multiplication, this one will be reversed, base 5. And from there you can reduce 2 here 1, 2 in 10 is 5. So we're left with log 625 divided by 5 base 5. And what was 5 is 6 to 5? 5 is 6 to 5 is 125. 5 is 6, 1. Give me that 1 in 12. 2, give me that 2 in 25 is 5. Then base 5. And you can see that I can now condense the number to be of this same base. So we're having log 125 is 5 is to the power 3 base 5. And from that log, 3 we multiply 5 base 5. Which base 5 is 1. That will be 3 times 1, which will give us what? TV. Another example. So now let me explain the one of change of base. If I have to simplify, let's say log 4 base 3 multiplied by log 9 base 4. It's very, very simple. All what we need to do here, you know you cannot simplify further here. All what we need to do here is use change of base. And how do you use change of base? I told you can introduce any base. So let's say log 4. Let's introduce base 10. Then log 3. I've changed this one to this now. Times, let's change this one to that will be log 9 and log 4. What do you notice? There's a particular logarithm that is similar that you can eliminate, which is log 4. So we'll be left with what now? 1 times log 9, that will be log 9, divided by log 3 times 1, that will be log 3. And from here, see that you change it back, or you simplify further straight away by condensing. We're having log this one to be 3 raised to the power 2, still over log 3 raised to the power 1, which is log 3. Then 2 comes to the power, that will be 2 log 3 over log 3. You can see that this one can eliminate this now. And that will give us what? 2. As simple as that. Please take note from here. Don't just say, because I'm having log 9 divided by log 3, that 3 will divide log 9. And you say 3 in 9 and 3. No. You must simplify step by step. Don't use this to divide this, so they are not the same. So you have that in mind. So let's consider another example. In this case, we're going to give an example under inverse property of exponents. Say for example, if I given 5 raised to the power minus 3 log 2 base 5 multiplied by 3 raised to the power minus 2 log 5 base 3. To solve this is very, very simple. If you can still recall that law, that if you have a raised to the power log n base a, the result will simply be what? N. So all what you need to do here is you try and change this to be in form of this by simply saying 5 is power log, that minus 3 now, you come back to the power, don't forget, base 5. Then times log, similarly minus 2, you come back to power, base 3. So what you notice? The same. It will simply be equal to the number. So this one will simply be equal to 2 raised to the power minus 3 times 5 raised to the power minus 2. And for me, this is negative power log into 1 over 2 raised to the power 3 times 1 over 5 raised to the power 2. And what 1 over 2 raised to the power 3? 1 over 8 times 1 over 5 raised to the power 2, 25. And that will give us what? 1 divided by 200. Let's consider one more example. If I ask to show that log a plus b raised to the power 2 base a is the same thing as 2 plus log 1 plus 2b over a plus b squared over a squared base a. If I ask to show this, it's simple. Since we are given log a plus b is power 2 base a, the only way we can show this is we find a means in which you can express this logarithm to be of the form of this. And how can we do that? You know, here this is addition. This is addition. It will not be easy to apply the laws like that. Assuming this is just AB, you know, you can simply say you can change this one back to addition by saying log AB is A plus log AB. But this is multiplication. Then how can you solve this? You try and find a means in which you can manipulate this so that you'll be having product of two numbers. At the end of the day, you can now separate. Now, same to here, you can simply try and introduce product like saying log a raised power 2, then multiply by what is there, a plus b raised power 2. But in this case, if you're having it divided by a raised power 2, you notice that this a raised power 2 will eliminate this a raised power 2. Then everything is base a. So what is there? Same as what is there. So the reason why we introduce this is because we'll be able to separate this one to what? To that multiplication, this one back to addition. So this will simply give us what now? Log a squared base a, then plus log a plus b all squared base over a squared base what? Base a. You can see that now. And this one will still give us this back. You can see that it's now getting closer. So as simple as that. So all we want to do is apply your law, or you expand first there. So from every time you say your time, you know that this one will give us what? 2 log a base a. But here now, since this is what we are having, you still need to expand this. And if we should expand this now, this one multiplies here 2 times. We are having a plus b into a plus b. And if we should multiply a times a squared, a times b ab plus b times aab, that will become 2ab plus b times b squared. So this one is a squared plus 2ab plus b squared. Everything divided by what? A squared. And this one will give us 2 times 1 plus, you can separate base a. You can separate it to be a squared divided by a squared, since this addition, 2ab over a squared, see the same thing, plus b squared over a squared. So this is same as this, where a squared is the same. You still get this. So 2 times 1 is 2 plus, and you're having log, this in this will be 1 like that, plus a in a squared will mean a. So we'll be having 2b over a plus then b squared over a squared. So you can see that we have proved that this, what is a, see second as what is a. Please don't forget to like, comment, share, and don't forget to subscribe. Watch out for volume 3 part 2.